Hello everyone. Today we are going to discuss about our fourth chapter, carbon and its compounds. Actually, chemistry is divided into different branches: organic chemistry, inorganic chemistry, physical chemistry, pharmaceutical chemistry, etc. This is the part of organic chemistry. Organic chemistry is nothing but the study of carbon compounds or hydrocarbons and its derivatives. First of all, we should know the versatile nature of carbon. Carbon have a lot of characters. Dear students, this is the first character, tetravalency. In the case of carbon, already we know the atomic number of carbon is 6. So the electronic configuration is 2, 4. You have total 4 electron in the last shell of carbon. So that is called a tetravalency. For obtaining the octet, carbon has to take 4 extra electron. Already we learned from 9th standard, valency is nothing but it is the number of electrons lost or shared or gained by an element. For carbon, for the completion of octet, carbon has to take 4 electron in its valence shell so that carbon can fulfill the octet and carbon can gain the stability of noble gas. So carbon have tetravalency. That is, the valence is equal to 4. Next, carbon is a non-metal. Every non-metal of the periodic table always try to get electron to fulfill the noble gas configuration. Do you know noble gas is highly stable because they have 8 electron in the last shell, but except helium. Helium does not have 8 electron in the last shell, but helium is stable since the last shell of helium is completely filled. So carbon is a non-metal. Next character of carbon is catenation. That is the very important character of carbon. It is the very important nature of carbon because in organic chemistry, you have 10 millions of organic compounds is discovered in these years. Up to this year, about 10 millions of organic compound is present in organic chemistry. It is because of only one reason, because of carbon. Carbon is very precious. Carbon have the tendency to form number of compounds. Why? Because of the catenation. Catenation is nothing but it is the ability to make chain. The self-linking property of carbon is called catenation. Carbon can form long chain, rings, cyclic compounds because of the tendency called catenation, because the ability called catenation. So catenation is the self-linking capacity of carbon to form long chain, rings, etc. Why carbon can form long chain? Because carbon is very small. Carbon have small size. See the last nature, carbon have small size. Because of the small size of carbon, carbon can enhance the long chains. That's why, student, I told you the formation of hydrocarbons. I told you the formation of alkanes, alkenes, alkynes. In every hydrocarbons, can you see long chain? Can you see carbon can combine with another carbon? That bonding, that type of covalent bonding is possible if and only if carbon have small size. Because of the small size of carbon, carbon can form number of organic compounds. So catenation is a very important property of carbon. It is the reason behind why carbon is forming about 10 millions of organic compounds. Next you have allotropes. Carbon can exist in different physical forms. First one is diamond, graphite, fullerene. All are the examples of the various forms of carbon. See, graphite is very soft. But what about diamond? Diamond is very expensive. It has high strength. In every allotropes of carbon, the basic element is carbon. If you are taking Buckminster fullerene, if you are taking graphite, if you are taking diamond, if you are taking coal, every allotropes of carbon consists of the element called carbon. So carbon can exist in different allotropic forms. Allotrope is nothing but it is the different physical forms of an element. Graphite can conduct electricity. I told you that thing because in the case of carbon have one free electron while it is forming graphite. If you are taking the structure of graphite, there is one free electron. That electron can move from one position into another position. That is called resonance. So graphite can conduct electricity. But diamond cannot conduct electricity. Diamond is an insulator. Diamond is an insulator. While graphite is a good conductor of electricity. Diamond is very strong. Diamond is very shining. Why diamond is very strong? Because of the presence of covalent bond. In the case of the allotropes of carbon, diamond is very strong, but graphite is very soft. Graphite is slippery in character, but diamond is very hard and strong because of the covalent bonding. That is the fifth character, fifth nature of carbon. Carbon can form strong covalent bond. Carbon can form strong covalent bond. What is the definition of covalent bond? Covalent bond is defined as it is the bond formed through the mutual sharing of electrons between nonmetals. Nonmetals can form covalent bond. I already taught you the presence of single covalent bond, double covalent bond, triple covalent bond. If you are taking hydrogen, you have single covalent bond. If you are taking oxygen, you have double covalent bond. If you are taking nitrogen gas, you have triple covalent bond. Triple bond is very stronger than double bond, which is more stronger than single bond. So covalent bond can be classified into three types: single bond, double bond, triple bond. That every different types of covalent bonds can be formed by our carbon. If you are taking alkane, you have full single bond. If you are taking alkene, you have at least one double bond between the carbon atoms. If you are taking alkyne, Y-N-E, alkyne, you have the triple bond. So, dear students, carbon can form strong covalent bond. But covalent bond is not much stronger than ionic bond. Ionic bond is strong. Ionic bond is very strong. After ionic bond, you have covalent bond. So, these are the versatile nature of carbon. Tetravalency, carbon is a non-metal, carbon can show catenation capacity, carbon can form allotropes, carbon can form covalent bond, carbon have small size. You don't forget the size of carbon, it is very small. The smaller size will initiate the bond formation towards carbon. So carbon can form number of organic compounds because the main reason is catenation. Catenation is due to the small size of carbon, due to the tetravalency of carbon. Students, think about it. Now in organic chemistry you have more than 10 millions of organic compounds. It has different characters: medicinal character, industrial character, catalytic character. So everything is because of the carbon. So carbon is an important element. That's why a new branch of chemistry is coming in the world. It is called organic chemistry. Dear students, today we have hydrocarbons. What is meant by hydrocarbon? In the name, can you see hydrogen and carbon? Hydrocarbons are formed by the combination of hydrogen and carbon. Hydrocarbons are formed by the combination of hydrogen and carbon. Mainly it is divided into three main types: alkane, alkene, alkyne. Can you see the difference? In first compound you have Ane, in the second compound you have Ene, in the third compound you have Yne. That Ane indicates single bond between carbon atoms. If you are taking alkane, you can see the single bond. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. In every class of alkanes, the 10 members of alkanes should have a single bond between the carbon atoms. So you don't, dear students, don't forget the criteria of the formation of alkane. The main criteria is the presence of single bond between each and every carbon atoms. You have methane, you have ethane, propane, butane, etc. I taught you each and every names of alkanes. After the alkane, you have alkene. At least one double bond between carbon atoms. You should have one double bond. You should have at least one double bond between the carbon atoms. You can start the example from ethene, propene, butene, pentene, hexene. I taught you the structure, everything in the theory classes. So that students, you can understand the difference between alkane and alkene. Ane make the difference. Ane stands for single bond. This Ene stands for double bond. What is meant by a chemical bond? A chemical bond is the forces of attraction between two electrons. If you have a force of attraction between two electrons, you can say it's a single bond. But if you have 4 electrons, 2 electrons this side, 2 electrons this side, this type of forces of attraction will make you the double bond. But in the triple bond you have 6 electrons. 3 here, 3 here. That 6 electron can make triple covalent bond. So a covalent bond is a class of chemical bond which can be divided into single bond, double bond, triple bond. All types of bonds have been shown by our carbon. Then the last type, alkyne. I taught you alkyne. You can see at least a triple bond in the case of alkyne. At least one triple bond between carbon atoms. You can start from the example ethine, propyne, butane, pentane, hexane, heptane, octane, nonane, decane. It is the number of carbon. I told you meth stands for 1 carbon. Eth stands for 2 carbon. Prop stands for 3 carbon. But stands for 5 carbon. But stands for 4 carbon. Pent stands for 5 carbon. And hex stands for 6 carbon. Hept stands for 7 carbon. Oct, it is standing for 8 carbon. If you have 9 carbon, you can say non. If you have 10 carbon, you can say dec. Dec is standing for totally 10 carbon. So that we can make decane, decene, decyne. You should understand one thing. At least a double bond is required for the formation of alkene. At least a triple bond is required for the formation of alkyne. So this is the different types of hydrocarbon. Already in our syllabus, many topics were deleted. So first of all, I told you the versatile nature of carbon. After that, now you have hydrocarbons. This is the classification of hydrocarbon. Dear students, now you have homologous series. Before explaining homologous series, I would like to share with you the knowledge of functional group. Every organic compounds have functional group. What is the functional group of alkane? Single bond. If you have alkene, the functional group is double bond. If you have alkyne, the functional group is triple bond. So functional group is the identity of an organic compound. If you have alcohol, the functional group is OH. If you have carboxylic acid, the functional group is COOH. If you have aldehyde, the functional group is CHO. So many organic compounds are present in this world. They have various functional groups. What about homologous series? It's a series of organic compounds. It is a series of organic compounds. What are the criteria for the formation of organic compounds? The first criteria is they have identical functional groups. Organic compounds having identical functional group are considered as homologous series. You can consider alkane is an homologous series. Alkene is a homologous series. Alkyne is an homologous series. So an homologous series should have identical functional group. The next criteria is they have same chemical properties. If you are looking at homologous series, they should have identical chemical properties. Same chemical properties. Why? Because they have same functional group. Functional group is the identity card of an organic compound. You, the students, have ID card in your school. That ID card can provide every information of you, from where you are coming, your address, everything is there, your classroom, your division, roll number, everything is there. Like that, an organic compound can provide this type of functional group. From the functional group, we can understand which class of reaction can be shown by that particular compound. The third character of homologous series is they have different physical properties. Don't you know, if you are going from methane, ethane, propane, butane, pentane, hexane, etc., the number of carbon atom, number of hydrogen, all are increasing. So the molecular mass is increasing. Dear students, if you are going from methane to ethane or ethane to propane, if you are moving from methane to decane, number of carbon atoms have been increasing. So their molecular mass should be increased. Because of the increasing of the molecular mass, they have different physical properties. Their mass will be changed. Their density will be changed. Their volume will be changed. Their melting point will be changed. Their boiling point will be changed. Whatever the physical characters, all should be changed because of the difference in the mass, because of the difference in the carbon atoms, because of the difference in the hydrogen atoms. So you don't forget the difference in the total number of carbon and hydrogen can make them show different physical properties. The last point is their consecutive members have been showing a difference of 1 CH2 group and a mass of 14 unit. If you are taking the members of an organic compound or a homologous series, if you are taking a particular homologous series, you can see same functional group. But the difference between the consecutive members of a homologous series is the difference in 1 CH2 group. If you are taking methane and ethane, you can see a difference of 1 CH2 group. Like that, if you are taking any two consecutive members of a particular homologous series, the principle is clear. There is a one difference of CH2 group. What is the mass of that CH2? Already we learned from 9th standard. A carbon have a mass of 12 and a hydrogen has a mass of 1 unit. You have 2 hydrogen. You have 1 carbon. So that carbon and hydrogen CH2, so you have 12 plus 2, total 14 unit mass difference can be shown between 2 consecutive members of a homologous series. So this is the last and final point. Consecutive members have been showing a difference of 1 CH2 group and a mass of 14 unit. So dear students, don't forget. If you are taking methanol, ethanol, propanol, butanol, pentanol, hexanol, whatever the homologous series, it may be an alcohol, it may be a carboxylic acid, it may be ether, it may be aldehyde, it may be ketone, it may be amines, whatever the organic class, whatever the classes of organic compound, whatever the homologous series, the main criteria is the difference of 1 CH2 group and a mass of 14 unit. So that is the points regarding to homologous series. It's very, very important. Homologous series and its characters are very, very important. I can repeat once more, they have identical functional group. They are showing same chemical properties, but they have different physical characters. And they are showing a difference of the consecutive members of a homologous series are showing a difference of 1 CH2 group and a mass of 14 unit. So thank you dear students for hearing my class. Bye.